Okay, in problem number 4 for Pythagorean theorem, the question reads, what is the length of segment SU? And SU is the base of this triangle, triangle STU. And as you can see, this is an isosceles triangle because I've got two sides that are congruent. ST is 8 and TU is also 8 units. Now in an isosceles triangle, from the vertex angle, both my median and my altitude are the same. So as you can see here, this segment, which is 6, is both the altitude, we know that because that's essentially the height of the triangle, and this is a right angle, as well as the median. And if that's the median, that means it divides this segment, SU, in half, which makes this segment congruent to this segment. That's for an isosceles triangle. So now we've got a right triangle right here. If we take the one on the left, we know that our hypotenuse is 8. We know that one of the legs is 6. And let's call this A. We need to find the length of this leg. When we find the length of one of the legs, then we can essentially double it to get the length of SU, which is what we're looking for in the problem. So we know that the Pythagorean relationship is a squared plus b squared equals c squared. A we are trying to find, we do not know, plus b, which is 6 units, equals c squared. Our hypotenuse is 8 squared. Take it down one more, a squared plus 6 squared, 6 times 6 is 36, equals 8 squared, 8 times 8 is 64. Subtract 36 on both sides. Now we get a squared equals 28. Again, our leg is not 28. That really would not make sense in the context of this problem. A squared is 28. So the opposite operation of squaring something is taking the square root. The square root of 28, if I round this to the nearest tenth, is 5.3, which means this leg of the triangle is 5.3. So now back to my original problem, the length of SU. If we remember, if this is 5.3, then this is 5.3, because in this isosceles triangle, the altitude and the median are the same segment. So my length of SU equals 10.6.